In this video, let's build my universal Commodore bench power supply that'll work on any Commodore machine that had an external power brick. I can't wait to get this thing working. So in earlier videos, we looked at the requirements, parts, design, and just an overall look at the project. Today, we're going to build and test it. If you missed the earlier videos, there's a link right here, as well as in the description below. I'm really eager to get this up and running because I get so frustrated when I have a Commodore machine come in with no power supply, or even worse, with one that'll destroy the machine. So what my goal is to have a single power supply on my workbench where I just have to change the cable to use it on any machine that I want to work on. So I planned this over many months and I know it will work, but I plan to use it for 6 to 12 months after this, and if I find major improvements, I'll do a follow-up video then. Otherwise, you'll find any improvements or changes in the blog post linked below. This project is based on off-the-shelf parts and should be doable by anybody who's doing their own computer repairs. But be aware there are exposed line voltages inside, so you do this at your own risk and don't power it up with those voltages exposed. So, without any further ado, let's get building. Prior to assembly, I did a quick test just to make sure that I had everything connected correctly, especially verifying the connections on the 9-volt transformer here. If you do anything like this, just be really aware of where you have high voltages. In this case, as soon as I turn this on, we've got high voltage in these two lines here, and high voltage running through these wires into the transformer. I do have some better voltmeters on the way, so you won't be seeing these mismatched ones in the actual build, but they do serve for now to verify that the 5 and 12 volt DC outputs are good. We can also verify through this meter connected to the output on the transformer that we've got our 9 volt AC, which is at 10.5 volts as we would expect since it's not under load. Because this is a dual winding transformer, you'll need to be sure it's wired correctly. I have this wired for 110 volts. If you're on a different voltage, then be sure to check the datasheet for proper connection. The change in plans when it came to the meters necessitated a change in the panel. This is the panel we've been working with up till now. It's worked and fit quite nicely, but we now only need 2 meters. And I did notice when unplugging the connector that it flexed quite a bit, so Tom has made an update. Now the panel looks like this. The connector is a little closer to the bottom for stiffness since there's only 2 meters there in the center, and he's added a rib section in order to stiffen it a bit. We'll start by adding the aviation connectors onto the front panel. There's a 4-pin for an external floppy drive and an 8-pin for the computers. You can put them on whichever side you prefer. I chose to put the floppy connector on the left, putting it towards the far side of the workbench. When installing the male panel connectors, be sure that the alignment notch is centered at the top, then just tighten the nut. When putting the meters in, make sure the decimal points are at the bottom. Snap in one side, then snap in the other. And there's the front panel, ready to be wired. So, one issue I ran into with the power inlet was that the connecting wires are the wrong colors. The red wire is connected to neutral and the blue is hot. I could not find any country where this was correct, but I do know that in the US the red wire is always going to be hot, so for safety and consistency I swapped them. If you want to check yours, then just connect a power cord and check it with a meter. When looking at an outlet in the US, the left wider prong is neutral and the right one is hot. Using a multimeter, you can check as I'm doing here. Be sure you don't do this with the cord plugged into the wall and that the power switch is on so you have continuity. This is the rear cover I'm going to be using. There's a blog post linked in the description below that details your cover options and has links to the STLs to print these yourself. It also has information on other cover options that you can cut yourself from plastic or the steel panels that come with the enclosure. All we've got to do to get this installed is to slip it in and add a couple of screws. And there we go, back cover done. We're almost halfway there. Well, halfway somewhere anyway. Alright, so in order to mount the transformer and the DC power supply in here, I need to drill holes, but I can't drill on the inside of the case. The transformer was easy since it's symmetrical, so all I had to do was grab a Sharpie. But the main well only has 3 mounting holes and they are not symmetrical, so I made a paper template and used that to mark the case bottom for drilling. Then we punch the metal for easier drilling and drill the holes. A quick note, use a proper drill. The Dremel is too fast and damages the bits. Unfortunately, our drill was not accessible at the time, so I had to make do with what I had. Finally, using the Dremel the way it was meant to be used, we removed the paint around the mounting holes to ensure a proper ground connection when the parts are installed. After drilling the holes, I went ahead and test fit the parts to make sure that they were going to fit and adjusted one hole with the needle file. One other thing we need to make sure of is that there's sufficient clearance for the power inlet. As you can see down in there, there's plenty of clearance. This is a prototype, so I figure I'll be in and out of it quite a bit, so I'm just holding everything in with these thumb screws I've had forever for PC cases. They just came out of my spare computer parts bin, but you can just use regular screws. So next, let's go ahead and take these back out so we can assemble as much as possible outside the tight confines of the case. While we're doing that, we'll just lay the pieces out for easy access. As I mentioned earlier, this is not the final front cover. I've got the new front covers being printed right now, but in the meantime, this will go here. I'll lay out everything so that the wires will fit with the covers laid flat. Then, once everything is done, they can just be lifted into place. The next part I want to prepare is the transformer. These will be mounted inside the case exactly like this, but we want to wire them up first while we still have easy access. I put these fork connectors on here while I was doing the test fit, but they'll get replaced because I don't want the wires this long. Looking at the data sheet, for 117 volts, we'll connect the supply wires to the main well's terminal strip where the AC mains will connect. It really doesn't matter which lead is the hot and which is the neutral. It's an AC transformer and it's pretty much symmetrical. We'll shorten the leads and attach them with a bit of slack like this. If I was building this to use as is, I would just connect the wires to the front panel with solder and heat shrink tubing. In this case, it's a prototype that I will modify over time, so I'll be using insulated spade connectors for easier removal and modification later. Because they're jacketed on both parts, you don't have to worry about getting short circuits. The kind I had before only had a hood on one side, so you always had a wire sticking out that could short to something. Now we just twist the wires together as shown on the data sheet for a 110 volt supply and crimp on a fork connector using a standard set of wire strippers/crimpers. We need to be sure to use the correct crimping position, in this case the 18 to 22 AWG position. One thing I learned the hard way, and a long time ago, is not to solder or tin your wires before using a crimp connector. The soldered wire does not deform in the crimp as it should and can work loose later. You can see the spade has a side that's flusher and a side that's got a little bit of a lip. You want the flush part up when you connect this because you're going to be adding a second spade for the AC mains supply later. You can also just include the mains wire in the crimp connector for a single fork. So next are the 9 volt AC wires. We're using a blue female spade connector on here because the two transformer wires are quite thick. We'll be using a red male connector later for the smaller wire for the front panel, but they'll still mate just fine. The difference in these is the size of the wire that'll fit. And that ain't going nowhere. Nowheres, I tells ya. These wires could probably be shorter, but since it's a prototype, I like to keep my options open. Also, because these are AC wires and there's no polarity to them, they can go either way, so there's no need to mark them because it really doesn't matter which way you connect them. Now that we have the transformer ready to connect to the front panel, we can move on to the next step. We're going to cut lengths of wire for each of the terminals on the main well and add fork connectors to one end of each. We'll add female spade connectors to them later once they're cut to length. Oh, I should also mention, when your wire coils like this, just put a little pressure on the opposite side where it's curling, like this, and you can take that out. It's worth the time rather than constantly messing with wire that just doesn't want to do what you want it to do. This wire is definitely longer than I need, but I'd rather it be a little too long than a little too short. Okay, so common is black. Now plus V2, it's labeled on the side of the mean well. V2 is plus 12 volts, and plus 12 volts is yellow. And V3 is going to be negative 12 volts, which I know to be white. And finally, of course, ground was green. Now I'm going to go ahead and connect the power inlet wires because this is pretty much all ready to go into the case. The yellow goes to ground. When you're putting two spade connectors in together, you want them to be like this so they'll go together. This way, they're quite a ways apart, and this way they generally will hold together. Optionally, you could tie those two wires together and just put a single connector on them. It's a perfectly good option. So now for the AC. We have the line and the neutral to connect. Well, it doesn't matter which ones go into which winding for the transformer. It does matter which one goes to which on your mains power. So you want to have the line be the red one, and the neutral in this case is the blue. Be sure you get these fairly snug. This is going to be your line voltage. Keep that in mind when you're working with this stuff. That's your AC, so there's a higher voltage on these. You want to make sure they can't short to anything, and you want to make sure that you don't handle this stuff while it's plugged in, ever. Hey, a tip. If I was smart, I'd have taken these off and done this one first so that they're not in the way. I look for things.
He is smart.
All right, so everything that goes inside the case is connected. Now all we have to do is take everything and feed it in through the back of the case and install the screws to hold them in place. Now we have all of our wires accessible and color-coded so we know what they are. Our AC panel is ready to go in, and I'll go ahead and put two of the screws in for now. Before we wire up the front panel, we need a strategy to keep things organized and sensible. For this discussion, we will look at the panel with the power supplies out of the case for a better view. The power table shown is also available on the blog post linked in the description below. Taking a look at the power table, and specifically the colors across the top, you can see that we've assigned colors for both the cables and the internal wires. The reason those are different is the pigtails are done with the 5-conductor cable. Since there's only 5 colors, some of them have to be reused, but we've organized them so that no machine will use the same color more than once. The internal colors are the colors of wire I'm going to use inside the case. Obviously, with exception to the wires that came pre-installed on things like the transformer and the power inlet. But for the panel, we're going to need to have 8 wires here and 4 wires here, and we'll also be connecting into the meters. So I'm going to cut lengths of AWG20 multi-stranded wire of the colors shown in the table for each front panel connector pin. You can use your own wire, but be sure that you use multi-stranded wire that is rated for at least 4 amps. If you don't use a different color for each voltage, then I recommend adding labels to prevent costly mistakes in the future. You don't want to accidentally connect your 12-volt wire to the 5-volt front panel connector and send that to a vintage computer. To solder wires to the connectors, we'll need to start by trimming some of the strands so that the remaining wire fits into the cup on the pin. Then we lightly tin the remaining strands, making sure not to add so much solder that it won't fit into the cup. Next, we add some solder into the cup, then insert the tinned wire so that the cut down strand fits into the cup and the full wire thickness is making contact with the top of the cup. Ensure that the wire and the cup are both hot enough to melt the solder. Then, once it's cooled a bit, add a piece of heat shrink tubing for insulation. Be very careful not to allow any stray wire strands to stick out where they could cause a short circuit. We'll start off by tinning each pin, leaving a little solder in each cup so they're ready to solder wires to. The first wire we'll tackle is the ground wire for the 8-pin connector. Since it's a center pin, we want to get it in first because once the other wires are soldered in around the edges, this one's going to be really difficult to get to. Next, we need to connect all the common black wires together with a single spade connector. This includes the common wire from each connector as well as the common wire for each of the voltmeters. The common wire is pin 1 on each connector. I also added an extension to the common wires to allow more slack when removing the front panel. After I added each wire to the front panel, I trimmed the corresponding wire in the case and crimped on its spade connector. 5 volts is red, so I added a red wire to pin 2 of each connector and crimped them together along with the red wire from the 5 volt meter. Next came the yellow plus 12 volt wires on pin 3 of each connector. These were crimped together along with the red sense wire from the 12 volt meter. The white negative 12 volt wire goes to pin 4 of each connector and they get crimped together. Finally, I added green wires with yellow stripes for the 9 volts AC on pins 6 and 7 of the 8-pin connector. Pin 5 is reserved for adding 9 volts DC for the Commodore 16 and 116. See the blog post link below for details on adding that option. And here's the front panel, all ready for testing. No sparks, no smoke. I'm hooked into the common already, so let's see what we got on the 5 volts. 5.125, that's just fine. And this should be the 12. 773, this should be the negative 12. Negative 12. Change this to AC, 10.5, perfect. So everything looks good. Connecting up the wires. So when you go to connect them, just see how snug they are, and if they're too tight, you can just take a jeweler's screwdriver and just loosen them up a little bit. You don't want them too loose, but you don't want them so tight you can't disconnect them. Also, when you crimp them, sometimes these get out of position, so you can just reposition them. You want them snug, you want to get a good connection, but you don't want them so snug that you can't get them back apart again. Kind of defeats the purpose of doing it that way now, doesn't it? All right, so now that everything is connected, let's see, shouldn't have any issues with any exposed wiring. Lay this on its back. Carefully tuck everything in there. There's nothing to short out. That drops in there. Real careful not to strip this. Fairly small screws into plastic. I'm going to flip her over. I only had 2 screws in the back, so let's get those in. And I do want to point out, if you're wondering about a fuse, I should mention that this right here indeed does have an integrated fuse. The fuse that comes with it's 5 amps, 250 volts. So that should work, but if it's insufficient, the power connector is rated for 15 amps, so I would be comfortable putting for this probably 8 at the most. And there it is. It's assembled. We'll have to see how well it works. The next step is going to be to check some voltages. I burnt that with my soldering iron. Poop. I'm going to start off over here on the drive connector. I think the easiest way to do this is going to be to remove the end off a female connector and plug it in to bring out the connections for easier access. Then we just need to plug it in and turn it on so we can do some tests. The voltages on the meters look okay. The 12 volt line is a little low, but it should correct itself once a load is applied. Pin 1 is common and 2 is 5 volts, which looks good. Pin 3 should be 12 volts, which is also looking great. And finally, pin 4 should be negative 12 volts. Perfect. Now we need to do the same on the 8-pin connector. Pins 1 through 4 are the same as on the drive connector, and they all tested fine. As I said earlier, pin 5 is reserved for 9 volts DC, so now we just need to switch the meter to AC mode and check the 9 volts AC between pins 6 and 7, which is exactly as expected. All the voltages check out fine on the front panel, so now it's time to make some cables. So I've tested this out on both the Commodore 64 and the Amiga 500, and they're working great using it. Because the meters take their power from the voltages they're measuring, the 5 volt meter is quite a bit dimmer than the 12 volt. There is a way I can fix that, but that'll have to be saved for the future. As I've been working on the section on cable making, I realized that there's a lot of useful information here that's not specific to this power supply. I decided to scrap these cables I've made and start from scratch with a much better way of making them and a much easier way of making them. So I will have that video up next week. I did decide to separate it from this video because there's, I think, a lot of value there. So here's a link to the video once it's ready, and in the meantime, here's another one you might like.